Welcome to the first video I'm recording on organic synthesis questions. These questions have been taken from the RSC Chemistry Olympiad, which runs annually, and on this PDF I've got two questions. The first one from 2001, the second one's from 2012, and the reason I've chosen the 2001 question is because it's significantly easier, in my opinion, than any of the others, so it's a nice one to start you off with, and then in later videos we'll look at more difficult questions like the one from 2012, for example. So let's get on with it. You can see here that we've got a synthesis which we turn whatever compound A is into compound G down here at the bottom, and we do this via a number of stages. We turn A into B, and then we produce this compound which we're told the structure of, and then we're told we can do a variety of reactions with this compound here, but we can also turn that into G. And I've chopped up the question into bite-sized pieces, and to start with we're just going to look at those first two steps up here. So here we've got compound A being turned into B, which is then turned into this molecule here, which is sort of our halfway house, if you like. Now, hopefully you will recognise functional groups here. Well, we've got an amine group here, we've got a benzene ring down here, and then we've got, it's not really a functional group, we've got a methyl group coming off that. But as A-level chemists, you should hopefully recognise at this point, well, concentrated nitric acid and concentrated sulfuric acid are used for nitrating a benzene ring. So if compound A was a benzene ring, and I'm just getting used to using the program again because I haven't done one of these videos for a while, so that's meant to be a benzene ring, we're turning compound A and we're nitrating it to form B. Now that's using conc nitric and conc sulfuric, and that forms that compound there, nitrobenzene. Now, in the second stage of this reaction, we're using hydrogen and a catalyst, and you can see that we're producing our amine group here. So that is a reduction reaction, and all that is happening is you're turning the nitro group into the amine. So that's, oh, and I don't know how I've done that with a rather large pen, but that's what's going on there, to turn the nitro group into the amine. Now the methyl group at the bottom has been unaffected by these two reactions, so obviously we need to start with a methyl group here, and that methyl group is untouched for the entire reaction. So we're actually starting with methyl benzene, and we're turning methyl benzene into 4 nitro methyl benzene, and then forming this compound down here. So on with the next step. Here we've got our compound which we've just made, and we've got a choice of 4 reactions: C, D, E and F. Now these all concern, I mean, you can see here, down here, that the methyl group remains untouched by that reaction, and the same is true all the way through here. It's very difficult to do anything with that methyl group. The chemistry that goes on in these reactions here affects the amine up here, and amines, like ammonia, have a lone pair on the nitrogen, and that means that the nitrogen can behave as a nucleophile, and if we have iodomethane here, that lone pair on the nitrogen can attack the carbon like that, and if it was bonded to an iodine, that bond could break as so. So what's happening here is the hydrogens, certainly for reaction C, the hydrogens in here are being replaced by methyl groups in substitution reactions. So you're getting, here's my N, there are my 2 methyl groups off it, and there is the methyl off the benzene ring, which has been unaffected by the reaction. Now the lone pair on the nitrogen also enables that amine group up here to behave as a base, i.e. that lone pair will be very attracted to any H plus ions that are floating around. And look what we've got in reaction D, we've got an acid being added, and that acid will be jam-packed full of H plus ions. So compound D is going to have our benzene ring, which has been unaffected. There's the methyl off the bottom, and instead of it being NH2, we'll get NH3 plus and Cl minus. Okay, so we're going to form an ammonium salt, and that's compound D. We'll come back to E in a second. F, we're reacting our compound with this species here. Now this species here is ethanoyl chloride. So we've got our compound here like that. And you can see that this carbon right here at the centre there is incredibly delta positive. It's next to a highly electronegative oxygen and a highly electronegative chlorine. So that lone pair on our nitrogen is going to be very keen to bind to here and replace the chlorine there. So compound F, we will have our benzene ring as normal, the methyl group off the bottom, the nitrogen, and that nitrogen will be bonded to the carbon which is attached to the oxygen and the CH3 group down there. Now that nitrogen needs another hydrogen just to make sure it's satisfied with its 3 covalent bonds. So that's compound F. Now what happens in E? Now hopefully you recognise this compound here which has been used in E, sodium nitrite. And sodium nitrite is used to produce this species here, which is called a diazonium salt. So I'm just going to draw out that diazonium salt, having seen this species here, I haven't actually drawn it. So the NH2 turns into N+, which is triple bonded to another N, and then we have the methyl group down here. And that reaction is used in dye synthesis. That diazonium salt is incredibly reactive, so if we were actually doing this in the laboratory, we'd have to keep compound E very, very cold to prevent it decomposing. And you can see that the examiner has told us that we're reacting E with CuCN, and the Cn replaces the N2. Now that's probably because, N2 is an extremely good leaving group, so the Cn comes in and replaces that, and then we react this compound down here with lithium aluminium hydride followed by water. Now I'm hoping that immediately you recognise that lithium aluminium hydride is a very popular reducing agent. It's an incredibly powerful reducing agent, and that reducing agent will turn our nitrile group up here into an amine group, and that's a very, very popular reaction on the Olympiad, turning a nitrile group into an amine. So it turns it into CH2 NH2, and that is compound, I can't actually see it on my screen here, but I think that's compound G. It's chopped off the G on my diagram. So that takes you through the synthesis. Sorry about the chaotic writing. It's the first time I've used this particular pen and a long time since I've used the program, but hopefully that shows you a route through an organic synthesis. They're usually a little bit more complicated than this, so the next one I try will be trickier.